All right, so today we're going to go over the second type of tissue in your body, connective tissue. We did go over epithelial tissue, and we talked about the glands, how the glands have simple cuboidal epithelial tissue mainly. They also have simple columnar, but I also found out that there are some types that have stratified columnar, and that one's actually kind of rare, but it's found in male urethra, the conjunctiva of the eyes, and found in your pharynx. Um, that's your throat and anus. So that's fun. Secretion, yeah, they do some secretions and absorption. I also found out that stratified columnar epithelial tissue is another type, not just the simple columnar, or sorry, cuboidal epithelial tissue. So stratified cuboidal epithelial tissue is also involved with secretion and found in sweat glands. That one's the one that's mainly found in mammary, or also found in mammary glands. Also, the circumanal glands, those are like around your hair follicles. They produce fat and oil, and salivary glands. So the stratified cuboidal is kind of upstream a little bit from the simple cuboidal in a lot of your structures. Um, yeah, I think pancreas is another one that is going to have um, some of your some of your simple cuboidal cells. But anyway, so a lot of them are doing different things, but in just or similar things in different areas of your body. And I'm not going to make you require you to learn every single detail about that. Just kind of the more of the general idea and the function and the general types of locations. Okay, but connective tissue found in all parts of your body, and it's the most widely distributed. Okay, does all the connecting. It has a common progenitor. It has a common cell type that it came from originally in embryonic development. So they're all related. They're all connected. They're composed of living and non-living matter. The living matter, of course, are the cells, and the non-living matter is called the extracellular matrix in this case. In epithelial tissue, we called it basement membrane because it was only found in the basement. Okay, and it might have been secreted, those might have been support fibers secreted by the epithelial tissue, or it might have been fibers secreted by the connective tissue underneath the epithelial tissue that was connecting the epithelial tissue to something else. Okay, and it does more than just connect, lots of functions. So the extracellular matrix of connective tissue are secreted by those cells themselves. They're very talented. The ground substance, we're going to call that's like what's in between all the structures. We're going to say it's made out of carbohydrates and proteins, and it can vary depending on the type of tissue. It can be very liquid. It can be watery, like plasma, literally like lymph. It can be gel-like, and it can be hard, like really hard cartilage or bone. All right. If the matrix is too firm for cells to move around, those types of tissue, generally the cartilage and bone, they have little tubs for the cells to live in called lacunae. Lacunae, which means lake in Latin. Okay. The fibers, that's the other part of this tissue. So ground substance, fibers, and of course cells too. But those are the fibers. They include collagen and elastin, mainly collagen, but some elastin. And it's going to depend on the type of tissue to say like what type of collagen, how much of it, and elastin. Right? Remember, elastin is that protein, that the fibers that are like coils on coils on coils, and then they can kind of like stretch back. We also have a type of like collagen fibers that are really thin, and we call them reticular because they just seem to be a particular reticular web-like, net-like sort of thin collagen fibers. They're all connected, and they're usually not in just one direction. All right. They provide a framework. So let's dive in. I've provided mostly some microscopic photos or some simplification of microscopic photos. But this photo, I want you to notice the main features here, the patterns are swirlies. Okay, swirlies. So what you're looking at is you're looking actually at a cross section of bone, and the center, very dark portion is the capillaries, or really the blood vessels. They do branch capillaries. These are the blood vessels. Yeah, bone is very vascular because it needs to do a lot of stuff. So it needs a good blood supply. Also, um, bone marrow is going to need the blood supply so that the cells that are made, the red blood cells that are made, can travel. So this is bone, also called osteo. Remember that's prefix for bone. Connective tissue. All right, so we have three types of cells in the bone. One are the osteocytes. Okay, so osteo means bone, cytes means cell, and they're just the mature bone cells. All right, they probably decide a lot of things. The blasts are the builders. So they actually build matrix. Try to squeeze that in there. And then we have a third type in bone called osteoclasts. And because bone provides calcium for your muscles, you got to be able to mobilize the bone. You got to break it down a little bit. And when bone has been injured, it needs to repair. If it's been broken, it needs to not just try to grow anywhere. It needs to kind of like deconstruct and reconstruct so that that whole bone is continuous and solid, and usually builds it stronger than before. So the clasts are the bone destroyer, and we need that to break it down. And that's what makes bone unique. I don't know of any other clasts in any other type of connective tissue or tissue. The matrix is hard and calcified with many fibers. All right, we actually have a lot of collagen in here. Yeah, did you know that? Your bone has a lot of collagen, and then it's calcified, and there's other minerals too. Sorry. Hard and calcified with many collagen fibers. Yeah, you are mostly made out of collagen because of that and other parts of connective tissue. There's a lot of collagen. Very good blood supply. I'll do that in a brighter pink. I should have done that. Because of blood. Yeah. Very good blood supply. We talked about that. Now, these little dark spot patches, you can't really see it because it's a bit of a view that's kind of far away, but that's okay. It's not zoomed in. How do you want to say? Magnified. Thank you. There you go. So those are actually where the osteocytes are. So those are osteocytes in their lacunae. Yeah. So bone is tough enough. It's going to need the lacunae for the cells to reside in. And then the blood vessels are actually in canals that run through the bone. And the guy, I guess, that discovered it was Mr. Haversian, because we call them Haversian canals. And then we do have like capillary canals for capillaries going, I don't know what you want to say, perpendicular to the blood vessels. Okay, so good blood supply. There's bone. You can recognize it because of the sort of circular shape that they tend to group around the blood vessels. Okay, so the next, I guess on my paper, I printed this out, sorry, so that the rest of it's over here. So its location obviously is in your skeletal bones, right? Skeleton. And its function, yeah, just like the skeletal system. So it supports, protects, so serves and protects vital organs, protects red bone marrow, and it stores calcium. Oh yeah, I should say that right here too. We'll add that. And I guess this next picture, that's cartilage, it's not bone. So we don't have any more pictures of bone over here. So the next section we'll jump into is the, hi Eileen, cartilage. I would say, like, you say hi to Eileen with your long bone, your forearm and arm, if you're waving vigorously, because she's a very good friend, Eileen. And that's how I remember that. The ends of the long bones have hyaline cartilage around them. So we're going to talk about cartilage, connective tissue. We don't have to really put connective tissue around there. they have two types of cells. So they have the chondrocytes that are just the regular cells that probably decide when things need to happen, and they're mature cartilage cells. And then chondroblasts, where I'm writing a little bit big, sorry. Chondroblasts, again, are the builders. So they build matrix. And what's the matrix like? Actually, it's kind of firm and rubbery. So, yeah. So it's got some strength to it. It's to keep the bones from getting chipped, you know. And then there's a moderate amount of collagen, a good amount of collagen, but there's some with more. No blood supply of its own, kind of avascular generally, okay? So I'm not going to do that in pink or red. So no direct blood supply, right? I'll just say no blood, but you know what I mean. So nutrients have to diffuse. These are found at the ends of your long bones, and I'm just going to switch colors so you can have some contrast here. Yeah, so you wave with your long bones. You're going to wave vigorously to your friend hyaline. So hyaline cartilage, but it also is found in your ribs. It's the costal cartilage of your ribs. Always try to put a D in there. Oh, that's hysterical. Hang on. All right. So that's your ribbies. Also, it's found in your larynx. So I guess while you're saying hi, Eileen, you're using your voice box. La 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 larynx. And that's what vibrates to make sound so you can speak. Go to Larry. Also, your tracheal rings, so you can keep your windpipe open so that you can breathe out and in and say hi to Eileen. Okay. Also, your embryonic skeleton before it's been calcified is all made of this stuff. Yeah. And it's still kind of rubbery when you're born, which is good because the baby's got to squeeze through kind of a tiny opening. So it's good if things, don't break. These tiny babies have tiny bones. What's its function? Support and resists, reinforce, and cushions, right? So it resists friction, force on it, I guess, reinforces, and it cushions. Keep your bones from chipping. So that's great. To look at these microscopic pictures, they aren't very good. They didn't turn out super well on the printer. I'm sorry. There actually is some fiber running through here. You can't quite see it, but we have a cartoon drawing. Helpful, huh? With the cartilage here, that's the hyaline cartilage, and you can see the little tubs. So these are supposed to be the lacunae. Yeah, that's a little exaggerated. That's okay. So these are the chondrocytes in their lacunae. They look like eggs, don't they? Right? And then the collagen's been sort of exaggerated, so it looks like bacon to me. So I feel like this is breakfast. Hyaline cartilage for breakfast. All right. In between's the matrix, and it's rubbery, maybe glycoproteins and others stuff in there. Okay, so you just can't really see the collagen in there, and I don't want to point to empty space. All right. So we're done with hyaline cartilage. Let's go to the next type of cartilage. We have three types of cartilage that we study. Fibrocartilage. And because of its name, fibro, you can assume, yeah, you're right. Lots of fibrous fibers in here. Collagen, mostly. All right. So cartilage, just like its sister, hyaline, has chondrocytes and chondroblasts. All right, so the chondrocytes are the mature cells, and the chondroblasts build matrix, just like before. And they look at all these collagen fibers here. Let's just point it out. And on the microscope, you can see it better. There's like these waves of fibers, bundles, I'd say. So yeah, they're supposed to be the collagen. Yeah, lots of bacon. And then you can kind of see that the cells look like they have a little circle around them. Yeah, those are the chondrocytes that are in their lacunae. I love to say it just in a fake French accent, by the way. Sorry, but that's okay, right? Lacunae. Then in between, very little matrix, as you can see. Like, there's not much space in here. All right. So you can just maybe point to space over here. So I hope you had a chance to print these out, by the way, because otherwise drawing these would be a pain. The Matrix. Yes, besides a really awesome movie. It's similar to Hyaline. Yeah. But the difference is much more collagen. Pretty much that's it, though. And then, of course, less matrix because there's less space for matrix. Oh, more, I'll say more bundles of collagen, less matrix. Cool, cool, cool. These are avascular also, by the way. They are avascular. Let's do that in blue, shall we? I'm trying to really bluer than this. Trying to use different colors so you can kind of see the contrast. There's a lot going on here. Avascular, and they actually are in pads of cartilage. Hint, hint. Does that give you an idea of where these are found at? It's where you're going to want there to be a lot of compressive shock absorbed. So its location, yeah, in the meniscus of your knee. So they're in the menisci of your knee. Whoa. I got excited. I can't spell this morning, so I keep like checking. Oh, also in your intervertebral discs, so between the vertebrae. Because you can think of like if you jump down someplace, that your spine like compacts down and could the vertebrae could crack. Also, your knees, you need to absorb. They absorb a lot of shocks, so that's why we need that. Also, in the pubic symphysis, between the pubic bones in the front, those two sort of your hip carriage, and they join in the front, and they have this disc in here of fibrocartilage. So yeah, because you could see how a lot of weight on those hips, you'd be putting a lot of strength or a lot of force, and you need a lot of strength. So its function, you probably guessed it, to absorb compressive shock. I know I used that as the location last time. Bummer. The third type is you can see this picture. You're like, what are all those tapeworms doing there in my breakfast? So you got the collagen, bacon, and you got the chondrocyte eggs. Yeah, that's actually the elastin. And it has like striation looking things because it's coils of protein. Yeah, elastic cartilage. Don't you love it? They name it like it what it is. Cool. So we can look at the picture and be like, yeah, that's still collagen, some collagen, but a ton of elastic fibers. And in the picture, I mean, I can kind of see, like in the microscopic copied picture, they look more grainy than normal than other pictures would look like. And so I tried to get something that was a little more true to life, what you'd see in the microscope. Again, you have the lacunae and the matrix in between. Okay, so just like you probably guessed it, these have chondrocytes and chondroblasts. Yes. So those are the regular, cells. And whoa, I wrote chondrocytes twice. Oh my goodness. Tired today. I have to drive to Seattle to pick up my daughter's cat. I mean, I have my husband going with me too, but it's gonna be fun. And it's supposed to be snowy on the pass, so fun. And drive there and drive back. Do day, do night. But the matrix is many elastic fibers along with some collagen, so it's really rubbery. So it kind of has a rubbery feel to it, more so than the fiber cartilage. It's avascular, so let's use, what did I decide to use for that? Like a blue marker here that's bluer than blue, right? So yeah, like when you get your meniscus of your knee torn, it's not very much blood. It takes a long time to repair itself, if it does, and this doesn't always repair itself super well. Sometimes there's jagged edges that are a little painful. It doesn't break itself down all the way and build itself back up like bone does. Elastic cartilage, probably the same way. I've never hurt these, so I don't have to worry because they're actually mainly located in the external ear and the epiglottis, which is awesome because they all start with the letter E. So you could remember that. Yeah, elastic cartilage, epiglottis, that's the flap that covers your windpipe, your trachea, so that the food and water goes past it and into the esophagus where you eat. But only the epiglottis has the elastic cartilage, and it needs to be able to be flexible and sort of seal and rubbery to seal, so it doesn't, when you drink water, you don't cough all the time because it doesn't go in your lungs; it goes to your esophagus where it's supposed to go. All right, so let's use green for the function. I guess we could say shape and support. Also, again, it protects the trachea. That's your windpipe. All right, so we got, yeah, to serve and protect, or support and protect. Sounds like what our beloved police officers do. All right, did you get that? I hope you did, because now we're moving out of cartilage land and just into some regular connective tissue. Literally regular fibrous connective tissue. And sometimes they like to call it dense because it's pretty dense, I guess. Lots of fibers in a regular direction. All right. So this one's a little easier to me to see in a microscope because the fibers all go one direction. Okay. Yeah, they're like a part of a boy band, and they supply support because if you're pulling, the direction of the pull is the direction of the fibers. So it really enables you to pull hard. Um, yeah, lots of collagen fibers. And the cells here we're going to call fibroblasts. All right. They just produce fiber. So there's no fibrocytes. Nope. Fibroblasts just produce fiber because, you get those little tears and you're going to need more fiber. Maybe you can kind of like guess where these are going to be at. So no lacunae, just fibers. I don't know. With the fibroblasts in between. So those are the nuclei of the fibroblast cells. And you can kind of see them here too. They're the little black dots are the nuclei. And then, yeah, fibers, like strong fibers going in one direction. So very little ground substance. That's the matrix. Let's try to write that down. And masses of parallel collagen fibers. Always want to put two R's in parallel. Okay, we got that. Poor blood supply. Okay, yeah, poor blood supply. What did we decide to put that in blue, like bluer than blue? Yeah, unfortunately. So it relies on diffusion of the fluid around it for repairing. So yeah, you're right. You guessed it if you guessed tendons and ligaments. So what it's, yeah, the location would technically be tendons and ligaments. So they're going to pull in a certain direction and be really strong in that one direction. And if it tears, it takes a long time to heal too. Yeah, if you've ever torn those, the time. Yeah, I play soccer. That's if you're wondering why I have so many injuries, because it's part of the game. Attaches muscle to bone or other muscle. That's what tendons do. They tend to attach muscle to bone or other muscle. And ligaments ligate to bones. Okay, they attach bone to bone. Oh, I have to put the A in there. Yeah, to ligate means to attach or to link. All right. So you probably heard of that. So sometimes they say dense regular. And then we also have this next one. Yeah, what's going on there? That's all over the place, right? It's dense irregular fibrous connective tissue. Let me see. I'm trying to decide what pen to use. We also say it's dense because look, there's very little matrix there. So a lot of times they add the word dense to it. And it is irregular fibrous connective tissue. The cells are also fibroblasts. They produce fibers. All right. Its matrix can be described as a tangled mass of collagen fibers, as you can see, or maybe a whole bunch of worm-looking things. Okay, at least in that picture. I don't have a microscopic picture of that. It's just all sorts of collagen going all crazy places. So maybe that's how you can notice it. I try to use my reading glasses for this, but then the glare is just too much, and you know, it's not good. Some elastin, okay. So it does have a poor blood supply in most. Also, there's just not much. It's kind of excluded there. In most, though, I didn't say all. I don't know. I don't know what the exceptions are. I just know that it's not all. But its main thing is it's tough in all directions, and the reason why is because it goes underneath your skin and it provides tensile strength in all directions, so that you don't just tear real easily in one direction here. All right. So dermis is of the skin is where it's located, but it's like the leathery part of leather. It's what makes leather leather. All right. Also, it covers soft organs and bones. So it covers, it kind of provides a nice boundary so those soft organs can remain autonomous, like your liver and your spleen, as well as covers bones. And I believe the perosteum is made out of this. That's the covering of your bones, and maybe the endosteum, because that's the inside of the cavity that it probably lines it to. This is probably in like the most areas, I'm gonna guess. I don't know, like most prevalent of a single type, but I don't know. I'm not sure. I can't remember that one. But hey, what's its function is to preserve and protect always, right? Supports and protects. Okay, yeah. It doesn't really provide any nutrients or anything like that. It needs nutrients. We have other tissue to do that. So cool, cool, cool. The third type that's kind of lumped in this category, you see down here. Oh, before I move on, look at this picture here. You'll see the cells. Those are the fibroblasts. Okay. You can see the collagen fibers. A little bit of elastin right here, just to make sure that it's not too brittle. As you age, your body makes less collagen for your skin because probably it needs it in other places, like to cover your internal organs and other places that's really important. And you lose elastin, you lose that elasticity, in your skin and it's easier to tear. So if you're taking off athletic tape or surgical tape with a person who's like 60 years old or above, do so with caution. Don't just rip it off because you don't want it to hurt, because that will hurt worse to take off skin. Okay, here's my pen. Then, all right, so the third type back here. See the picture? It has just a ton of elastin. Fibroblasts, yeah, we're talking about like fibrous types of connective tissue, but this is the same. And tons of elastin. Okay, fibroblasts, yeah, but the elastic is the main feature of here. The elastic connective tissue is what we're going to call this, all right? Yeah, it's made out of fibroblasts. They produce fibers. And if you had to describe the matrix is usually waves of parallel elastic fibers. Usually they're in a certain direction, I guess. I don't have a microscopic picture of that one either. It's needed where recoil is important, and yeah, it's not. I mean, I'll just say that. I'll do that here. And generally, where it's located, it's right next to where there's a blood supply already. So they don't have to have their own blood supply. Just like the regular fibrous connective tissue doesn't have a blood supply, elastic connective tissue doesn't necessarily, because it's going to be located in your arteries and the alveoli of your lungs. So yeah, it's going to get some nutrients that way, I imagine. Though it's on the outside of your arteries, well, the inside of the outside, I guess. Remember, the inside of the arteries have simple squamous epithelial tissue, so it's real smooth. But then after that, your arteries have this elastic connective tissue, and it's to maintain your blood pressure, also to keep your arteries from like tearing from like immense blood pressure. If you had every time the heart beats, you would be in danger of tearing, perhaps. So the arteries need to go back into shape so that you don't get too much back pressure when your heart beats. So the blood is generally going down to the rest of your body and away from the heart with oxygenated blood like arteries do. So it needs to help maintain blood pressure. All right. And I guess, and it protects the arteries from tearing. Okay. The alveoli means honeycomb, I guess, in Latin. And that's where the air from all of the bronchial tubes goes eventually. And remember, there's the simple squamous epithelial tissue there too to allow diffusion to occur. But if you breathe in, there are like millions of little tiny air sacs. Those air sacs need to be able to expand and then come back, so we can exhale. And then once you exhale, you might compress them. You need them to come back to be able to receive air in again. So its function there is going to be recoil during exhale to move air out, and inhale for air in. There. Okay. So again, it's going to get enough oxygen. These fibroblasts should get plenty of oxygen at least at that location. All right. Cool. Next, we're going to move on to sort of a softer tissue, less dense. Here we go. Let's make sure you got that. To me, these pictures look like something that you might climb during rock climbing. And what those are little tiny collagen fibers, sorry, and they're like sort of snaky and web-like, so it provides a netting, right? So we call them reticular fibers. Yeah, and just looks to me like the edges of the rocks, but that's okay. And then, of course, you have cells around them. So we're going to call this, I love this, reticular connective tissue, right? So that they're in like a little netting. The cells themselves. Now, this is that's interesting. Is mainly these are your soft organs, and so the cells of the reticular connective tissue are the cells of the soft organs. So, does that mean that your liver cells is it just a type of connective tissue? I guess so. I don't know. It makes sense because there are four types of connective tissue. I would assume so. So that's all I know is that the cells of a particular organ are what makes up the reticulated connective tissue, and maybe they're the ones that produce the fibers because I don't have any other cells there producing fibers. So yeah, the matrix would be soft with web of the reticulated fibers. Soft matrix, but fluid. So I guess we need to also say fluid because yeah, it has some fluid wandering in and out. This it has a good blood supply though. All right. Yeah, because your organ is doing stuff, and so it needs a good supply of nutrients. Yeah, and sometimes it creates a product like your bone marrow is going to produce red blood cells, right? So yeah, its location. Oh, lymph nodes is one location. I guess did I decide to make that in? I'll make it in. I don't know. Lymph nodes. So this tissue supports the cells of the lymph nodes. So fluid can go in and out. So we can your immune system can monitor the blood and the lymph. So it probably has lymph in the lymph nodes as the matrix. It's found in your bone marrow. Yep, which is pretty soft. Your liver. Remember, your liver also has to create molecules and convert vitamins and detoxify the blood. So it's going to need stuff wandering through and lots of blood cells, and your spleen, which is going to be monitoring your blood for worn out blood cells. So its function, well, that web of fibers actually are there to trap tissue fluid so that the cells have a chance to counteract whatever's in the fluid or secrete stuff into the fluid that might get picked up by little capillaries. So as web of fibers, they trap tissue fluid. Remember we called tissue fluid different things depending on its location, but it also supports cells um, so that they can do their function. All right, provides a little matrix for them, a little netting. All right, that's all she wrote for reticular connective tissue. The next one is not dense; it's pretty loose, and that's one name for it, or areolar connective tissue. Um, so it has a couple different names. I always think of like areolar area around your nipple, when female mammary glands, nurse. Um, so actually, I think of these as like the nursemaid, the nurse of the connective tissue, or of all your tissue, really. So what we have here is a smorgasbord of different things. We do have fibroblasts, but we also have some immune system cells, like a macrophage, phage, pH, and white blood cells. All right. And they activate the immune system. Oh. It has a good blood supply. So you can see the capillary there. Maybe I should start like labeling that, or we'll talk about it first and then we'll label it. Matrix, tissue fluid, widely spaced collagen and elastic fibers. Yeah. What color did I decide to make those? I don't know. So a good amount of tissue fluid and widely spaced collagen so that the cells can wander and do their jobs. Because, red white blood cells have to wander back to the rest of your lymph nodes to activate the immune system responses. We have some elastic fibers to keep it fairly rubbery and it's the vascular. Okay, so we talked about that's the capillary right here. That's what it's supposed to be in the little cartoon. Can't see it here because maybe you can. I don't know if that's supposed to be a capillary or not right there, but like the regular cells, maybe that's a cross section of a capillary there. Looks like the fibroblasts, maybe those are white blood cells. That's a fat cell, by the way, an adipocyte. So, I guess it has adipocytes here too. And there's some collagen here, with a 4-year degree, I guess, because it's collagen. I don't know, maybe ended up with 3-year. That's fine too. Yeah, it's the most abundant because it actually feeds other cells with nutrients. That's why I have this smorgasbord. So it will protect it by activating the immune system, but then also provides nutrients and takes away waste. Super helpful. So it's very important. Luckily, it is the most abundant type of tissue. Sorry, I wrote on that. So you can kind of see the collagen fibers in here. How do you tell them from the rest? Well, there's more space in between than maybe the dense, irregular connective tissue, of course, and stuff like that, other tissue. Where is it located? It is under your skin. Remember we talked about how your stratified squamous epithelial tissue, it doesn't have good blood supply. As it grows, it creates lots of layers. They get farther and farther away. And what's providing the nutrients underneath that is areolar tissue that has the capillaries, and then oxygen's going to wander, glucose, other things. But if the cells of the epithelial tissue get too far away from the areolar tissue that's under the basement membrane, then they're going to lose connection with enough nutrients to survive with it, and then they're going to die, but that's okay. Remember, your skin has a nice protective dead layer. That's good. So you're not just, you're not dead inside, you're dead outside. So its location is under your skin, maybe mucous membranes. By the way, the joke. I was just kidding. And around body organs. Anatomy teachers have a really sick sense of humor. And cavities. Yep. So it's going to, monitor immune system wise and serve and protect. What does it do? The white blood cells destroy pathogens. And all connective tissue or epithelial tissue obtain its nutrients from this, I guess. So yeah. I guess. I have this in my notes. Oh, but you also need to release your waste into it. All right. So we have the second to the last type of connective tissue, and it's the fun one because it's the adipose tissue. Cool. That's the fat tissue. Yeah. Did you know that you're born with as many adipose cells as you will ever have? They just get bigger and fatter. So these can see that how the nucleus is like shoved to one side. Yeah, that's just a lot of fat in there. So the type of cells in there are adipocytes. Unfortunately, another time in your life that you can get fat cells is when you're pregnant, if you do get pregnant. So I mean, that's good. You need the fat for the energy and cushioning and stuff like that. So it's really important. The matrix, what is it like? There's not much of it. There's no room. Just the adipose cells. So they're just tightly packed in there. No room. But it is soft and gel-like. Okay? Yeah, for cushioning. It's genius because fat doesn't actually weigh as much compared to how much energy it will provide you if you're burning fat. Question is, how can you get to fat burn and not burn up your muscles? Yeah, your body will take protein and use it, unfortunately. So let's see, like reticular fibers are there in between. So those are these guys, and they support the cells. That's it. So there's enough room in there for some fluid in there. Blood supply is good because there's a capillary right there. That's what that's supposed to be. There's collagen, by the way. I think that's a cross section of, these are cross sections of capillaries. Ooh. Okay. So just very little, if there's any collagen. Yeah. So it's vascular. I guess we need to make sure we fit that in there. Sorry. Vascular. I can't. Where are we? Okay. So tired today. It's been a week. So because it has capillaries, it's definitely vascular. Cool. Description is tightly packed fat cells. Okay, you probably have guessed that. What should we do that in here? That's the adipocytes. Where is it located? Subcutaneous tissue. Okay, so the types of places under your skin where you have fat cell, like around midsection, possibly. Sometimes around muscles. You get a nice marbling in your muscles. If you're a grazer, you'll get good. I'm gonna write over this because yeah, running out of space. Also, it's in and around your eye. Yeah, your eyes need it to be able to see. That's a danger of people who get too skinny, as their body will take that fat around their eye and their eyes will be sunken. They won't be able to see very well, and it's not healthy. It's also around your kidneys to try to cushion your kidneys. All right, so what is its function? Let's pick this one. Or can we pick another color? Do I have another color here that's decent? I feel like I should pick orange for that, I don't know, just because. When you do have brown fat, that makes a more, actually, the cells actually tend to burn, when they use the energy in those fat cells, it makes a lot of heat. Okay, so it stores excess chemical energy. And it's very efficient because it doesn't weigh very much. Density-wise, it's not very dense either. All right, whoops. Cushions, supports, almost done, protects, and it does insulation. Yeah, it keeps you from getting too cold. That's why bears they eat the fatty parts of the salmon, and they try to get nice and large, and it protects and insulates them in the winter time so they can get through without having as much food. Okay, the last type of connective tissue doesn't look like much under the microscope because its matrix is so watery. Yes, I don't know if you guessed it, but it's blood, right? So the red blood cells made in the bone marrow of that reticular type tissue inside of your osteo tissue, connective tissue, then the red blood cells will join the plasma and create blood. So these are supposed to be Red blood cells. These little tiny dots are the tiny platelets. Yes, that are involved with clotting. And these are supposed to be different types of white blood cells. I don't know. Okay. Cool, cool, cool. The plasma is the matrix. And there's a lot in the plasma. Like you definitely have a lot going on in your blood, all kinds of blood factors, nutrients, waste that your kidneys are going to try to filter out. So plasma has a ton of dissolved particles. And if you have some lipid in there, some type of fat or oil, it's probably got because water, plasma's in water, it's very polar liquid. It probably has a protein polar protein escort is what I'm trying to say. So that's how you can get lipids to travel in your blood. Is how you can get non-polar things to travel in your blood. So the types of cells, red blood cells, we all know that they carry the O2. Sometimes they say they carry CO2, but not in reality. Like you don't want them to carry CO2. You want them to carry O2, CO2 a little bit, but CO2 mainly dissolves in the bloodstream. Yeah, I wonder if you had way too much CO2, if your blood would actually be fizzy. I don't know. That'd be sounding dangerous. Too high levels CO2. So white blood cells, they fight infection, right? They initiate the immune response. Platelets are for clotting. All right. Matrix. It's plasma. Yeah. Okay. Well, we're just gonna break all the rules and just be like, here. We use pink. Yeah, because I guess it's vascular because it is blood. Bah. So plasma, liquid, matrix. Remember, H2O is the solvent. Yep. Fibers are soluble proteins. So if there are fibers in there, by the way, and the fibers change shape when your blood thinks that there's a bleed and that you're losing blood, or if your blood pressure gets too high, it thinks that you're bleeding out. These fibers will help clotting. Within blood vessels, that's where this should be located, we hope. Should we pick a different color, like red? Yeah, this is blood. We should have like red. That looks kind of orangey, but that's okay. Within blood vessels. Maybe it is orange and I'm just colorblind. I don't know. I'm not colorblind. It's okay. And chambers of your heart, right? You don't want the blood other places. Your plasma might kind of ooze and flow between capillaries and the other extracellular matrix and the lymph system, but the blood vessels themselves generally stay in the blood, at least red blood cells do, until they get old and then your spleen takes them out of your blood. And white blood cells, they do need to wander a little bit into the lymph system to sort of contact other white blood cells and initiate your immune response. What is its function? It's to transport O2. I don't know, let's use green here. And CO2, of course. And nutrients, other nutrients, vitamins, minerals, yeah, glucose, etc. Throughout the body. Oh, can I get the word throughout here? I did. Throughout the body. Also, you have chemical signaling molecules that need to be transported. So hormones are chemical signaling molecules that travel in your bloodstream. Also, it's going to act as defense and immunity. And clotting. Yep, if you get an owie and you're bleeding, your red blood cells will initiate clotting. I don't know if you can see that. Okay, cool. That rounds out our connective tissue. Thank you so much for joining us, and I hope you're having a great day. Let me know if you're not, and if you need any if you have any questions you need answers.